Okay,
Okay.
Doctor.
Okay, all right. Because actually I have a meeting at 2:30, so I can only spend half an hour with you. But anyhow, you could, try doing all the exercises yourself, and then we can compare the answers together. We'll discuss the answer together. Now, last class we actually stopped here, which is activity 2.16. All right. So let's look at how we solve this. This is a trapezoidal channel. So basically, you may sketch the section out, and then I think let's go to the other. Uh, I have another file which has all the answers provided already. All right, here. You have a trapezoidal channel, so you might sketch out 5 meter bottom width. All right. And then, all right. Have we gone through this exercise before? Not yet, right? Guys?
Not yet. Not yet.
Okay, great. Okay, it's a trapezoidal channel. Now, this is not as straightforward as before, where we were asked to find, the longitudinal slope, the width, bottom width of a channel, all right, even the side slope, right? We actually have to write our uniform flow equations, which are the Manning and or Chezy equation in terms of section factor, because section factor, by definition, section factor is a function of depth of flow. So when the question asks us to find normal or uniform depth of flow, we need to rewrite, the Manning roughness flow equation or Chezy roughness flow equation in terms of section factor. And then we have to solve it. It's not direct, except for triangular section. Triangular section, you can solve it directly. So for indirect questions, for indirect sections, you need to master your try and error. Oh, I think I forgot. I mentioned that I'm going to share with you, a YouTube video where it teaches you how to solve, using your calculator, how to solve try and error equations, right? Remind me later, right? I'm going to share it with you later. Just remind me again. It might slip my mind because sometimes it's just I have to run to another, cater for another stuff, so I tend to forget. Now, of course, the flow area, all right, for a trapezoidal section would be b times y plus zy squared. Right? You have half of zy squared, half of zy squared. Therefore, you have therefore you have zy squared. So the flow area is that. Now, the flow area actually is written in terms of y, depth of flow. I think you have similar question in assignment 1 where you need to find depth of flow for critical depth. All right, you need to find the depth of critical flow. All right, so you need to write the flow area as well as the vector parameter as a function of y. All right, it's the similar problem here. And then vector parameter will be b plus 2y square root 1 plus z squared. So therefore you have 5 plus 2 square root 3.25y. And then hydraulic radius therefore is a divided by p lah. All right. You have there, that is the expression. And then now you know that all these values, right, you could substitute straight away in the Manning roughness coefficient because Manning roughness coefficient is provided. So substitute in the Manning roughness flow equation. So rewrite this in terms of section factor. So A and R is as function of depth of flow. So you have your Manning roughness flow equation rewritten here. So you substitute as I mentioned earlier, right? If you are not good at you, if you tend to make mistakes, right, of combining your A and the A in your R, in your hydraulic radius, right, you may leave your equation like this. But of course, you need to enter longer equation in your calculator in order to solve it. However, if you are good at combining, you can combine it. It doesn't matter. All right, you could use both expression. This is a combined version where I combine the A because in bracket they have the same value, right? So this term times this term, right? Of course, it's just the addition of the power. All right, I have 5/3 because this is 3/3, right? Equals to 1. 1, you could, you know, it depends. It could be 2/2 still equals to 1, 3/3 still equals to 1, or any other numbers. As when you cancel it off, it still becomes 1. All right. So by making the denominator as 3, you have 3 divided by 3 plus 2 divided by 3. Therefore, you have 5/3 lah, basically. So this is your P term. All right, vector parameter term. Solving Qn over S naught half, you are going to get 16.04 lah. All right. So solving this, all right, you need to, enter this expression in your calculator. That means in bracket 5 times y plus 1.5. Then you solve for y, basically. It doesn't matter what symbol that you are using for y not. You could use x, all right? I think your calculator, you have x there, right? So you could use x. Well, you know that your x is actually your y, right? So it's solving it. When you press the button solve, it gives you 1.82 lah. All right. Just try to do all this yourself. It's very important. From chapter 2 onwards until chapter 4, you will be dealing with all this try and error. So you have to understand this. This is manually, all right? I said calculator straight away give you this answer. But manually, all right, if you try 1, all right, it gives you 5.391. If you try 2, 19. So you know your answer is between 1 and 2, all right? So I guess it's near to 2 lah, all right, because it's 16, which is nearer to 19. So 1.8, therefore, you try it again. By substituting y naught equals to 1.82, you are going to get 16.035. Let me tell you this. Last time, during my time when I was studying, we don't have scientific calculator. So we have to do this table. We have to try one by one. All right. So you are lucky because you have scientific calculator where you can, key in all this expression, then just press the button solve. You don't have to calculate it so many times. We do, all right? We do. Depending, I told you, depending on type of question, depending on the instruction of the question, if the question asks you just to solve the depth of uniform flow, you could use any method, it doesn't matter. But if the question specifically asks you to solve it using graph method, then you have to plot this out. Therefore, you have to show the table, all right, with the points, the value there. This term will be AR to the power of 2/3. Okay, this term. Okay, you just have to get few points, all right. Minimum 3 points, all right. Minimum 3 points where this 16.036, right, should be covered, within, for example, in this 3 point, no, sorry. You could have 1.72, all right, because 16.036 is within this, all right, within 1 to 2 range. You could have any 3 points, right, between 1 to 2. If you give me 3 points, 1.5, 1.7, you actually won't get the answer because the 16.036 is actually outside from this range between 1 to 1.7. I hope you understand. This one here, this, when you substitute y naught into this term here, it should actually give you 16.036 in order for you to get the correct y lah. All right. So therefore, the correct y will give you exactly 16.036. So, you know, the instruction itself, all right, you solve it using graph, so you need to draw a graph, all right. So therefore, I told you you don't have to connect it to, you know, 0, 0. Therefore, you have 6 points here, all right, x and y coordinates. So you just, you know, plot it out. So on the x-axis, right, you locate where 16.036 is, because you need to find y for this AR to the power of 2/3 value of 16.03. Draw a straight line. When it cross or intersect with your graph, you could actually find the value of y naught. The value of y naught, yes, is correct, which is between 1.5 to 2. All right, so you can read it from your graph, 1.82 meter. Now, you may ask me, do you need graph paper to solve this question if the question asks you to use graph method? Not necessary. If you know in your piece of paper you can have the correct scale using your ruler. That means you can draw out the scale using ruler. It doesn't matter. You don't need purposely to find graph. But normally, if you have you know, question where you need to use graph paper, we will provide you the graph paper. But you may opt not to use the graph paper if, you know, for example, like in this case, you can actually, if you draw using the ruler, draw out the scale using the ruler, you still would be able to find almost accurate result. All right. It won't, you know, it won't differ as much as 0.1 lah, I believe, or 0.02, 0.2, all right? You still get almost the same answer lah, all right? The third method, this is what we have also learned in our last lesson. The third method is using design chart. Again, any one method. It depends on the question. Some question may ask you to use all three methods, so you have to show all three solution. Sometimes the question doesn't even state asking you to use any method. So the best method would be, you know, use calculator to solve it. You can get the solution straight away. Okay. Now, it's a you know, trapezoidal channel. You know, the side slope would be z equals to 1.5. So you know this is the line, right? This is the line here. Your AR to the power of 2/3 is actually 16.03. Is it? Oh, no, no, no. I think you need, sorry, AR to the power of 2/3 is 16.036, but you need to divide by B. Your B would be 5 to the power of 8 over 3. All right, so therefore you are going to get a value of 0.2194. Then draw a straight line, okay, a vertical line. When it hits the line of Z, where Z equals to 1.5, all right, intersect with that line, you just, you know, that is the blue line lah, all right, shown. You just draw a line to read your Y over B, boy, B for boy, value. If you look at the graph, all right, provided the design chart provided, it should give you around 0.37. Okay, so y over b is equal to 0.37. Therefore, your y is b times 0.37, where your b is 5 lah. All right. So therefore, sorry, your y is 1.85 meter. Now, this is one design chart that I'm showing here, all right? So in this slide here, there's another design chart, all right, for line open drain. Basically, where does this design chart come from? Depending on which standard you are using. For example, this is from Urban Storm Management Manual for Malaysia, which is published in 2000. Actually, this Urban Storm Management Manual for Malaysia, there is a current version which is published in 2012. Now, speaking about this manual, right? This manual is also known as MASMA, Manual Saliran Mesra Alam Malaysia, which is the abbreviation would be MSMA. All right, MASMA. I have actually upload the MASMA 2012 edition in the author, all right, for your project. All right, I think some of you may have already seen all those documents that I have uploaded for your project. I'm going to talk about, I'll spend last 5 to 10 minutes to talk about the project. Okay. Um, Now, this is, different type of design chart, which would also be provided for you lah. All right. What you have to be alert of, you have to look at the X and Y axis. What are the terms, all right, that they want, the expression provided. So basically, given once you solve one axis, all right, you should be able to solve the other axis value. Of course, your Z is provided lah. For example, in this case, right, still using Z. You see, why initially in chapter 1, I introduced the Z. Even in this design chart, right, they are still using the Z, which is the horizontal scale for the side slope. So it's very important to standardize it, all right? All right. Okay, we have here another activity, which is actually activity 2.16. In your notes, this is 2.16. Again, this is a trapezoidal channel. You need to find bottom width, all right? In this case, it's bottom width, not normal depth. So you need to find D. All right, all are given. Right, you straight away. The unknown also A and P. You couldn't solve it, A and P. So you have, in this case, you also have to write your Manning. Is it Manning? Yes, Manning coefficient is given. You also have to rewrite your Manning in terms of section factor. All right. So therefore, in this case or question, it's a B that we need to find. So the same way you solve for it, try and error. Just substitute in your calculator. You are going to solve it, and then you will get your bottom width equal to 16.33 meter. All right. Try and error using normal depth. This is a rectangle channel. You could try this out. Okay, I'm going to provide, since this is a recorded, all right, video, our session here, I'm going to upload this YouTube on YouTube channel. So you should be able to look at the solution. You can check your solution. Right, the try and error is, by try and error, your depth is 1.942. I'm not going to go through, you have to try this out, all right? Because it's repetitive, I'm just providing you more exercises so you can practice to get ready for your assessment, test 1. Your test 1, do you remember when is your test 1?
Yes, doctor.
It's April 26th. That means it's 2 weeks away. All right. The week after next week, all right, that Monday would be your test 1. Test 1 cover chapter 1 and chapter 2. We should be able to finish chapter 2 by then. All right. Of course, I think in that afternoon, before your test 1, or from Thursday, all right, that Thursday, I'm going to help you study for your test lah. That's one, all right? Okay. All right. Activity 2.12. It involves circular channel. You have learned, right, the 2 theta. In this case, right, since the depth of flow is less than half of the channel or circular section, your 2 theta should be less than 180 degree. All right. So if you are going to find 2 theta, of course, it's going to be less than 200 degree. Okay, look at this question here, 2.12. Diameter, which is the D, is 2 meters. So half of it will be 1. So your R here, look at this. Your R is 1 meter. Okay, because your R, all right, the radius of your circular section is half of D. So R is 1 meter. Okay. S naught is 0.004. Manning roughness is 0.014. Q is 2 meter cube over second. All right. Now, you need to find Y naught. Now, the first thing that you need to find would be, you probably want to determine, of course, you could find Y naught. Okay. Now, since, okay, here's the thing, I believe you could not find Y naught straight away because your A is written in terms of D squared over 8. Your vector parameter is theta D. So the first unknown that you are going to find is theta. Okay. So your theta would be written in terms of R. Okay. In this case. Okay. Here's the thing. R or Y lah. It doesn't matter. Okay. Now, let's solve for theta first, all right? So you actually, for flow area, you can substitute your D, the diameter already, and vector parameter. So the only unknown will be theta, all right? So therefore, okay, rewrite your Manning roughness coefficient because Manning roughness is given, right? 0.014. So you have that and substitute, all right? In this case, is it using design chart? No, in this case, I show you design chart. But anyhow, you could actually solve using your try and error too. Now, for design chart is simpler because if you look at, is it here? Right, wait, just a second. Okay, it's here already. Okay, design chart is simpler because the term here, AR over 2/3 divided by D to the power of 8 over 3, you can actually have this. That means your QN over S naught to the power of half is actually the value for AR to the power of 2/3. That means you just divide by the diameter to the power of 8 over 3, right? Okay, in this case, you solve this, you get 1.4, you divide the diameter to the power of 8 over 3. So you are going to get, your axis value, which is 0.2205. So using design chart, now in this case, it's very simple. Using design chart, you don't have to do try and error. You just draw. Okay, the first line would be the circular section. Just draw a straight line, intersect with your circular express line diagram. Then you can read your Y over D naught. Okay, so your depth of flow is, your value is about 0.38 like that, okay, times D, all right, which is 2 meter, right? So you are going to get 0.76, Y, all right? Where's the answer? It's not here, is it? Okay, I think I didn't provide the answer, but you could try it out. Now, I would suggest you, if you want to do try and error, you can try it out. Okay, I'll provide you the solution if you want to try this out. This is not difficult, all right, to get your theta. Not difficult at all, all right? Okay. Now, okay, exercise 7 is now previous exercise. We actually have simple section. This is a compound section where it's a combination of a triangular and a rectangular section on top of the triangular section, all right? So you need to find the flow rate is 23 meter cube over second. All right. You need to find Y naught, Y naught. And then bed slope Manning is 0.015. Is actually concrete lah, all right, or similar material of lining. And then the bed slope is 0. Oops. Sorry, I think my connection is not very good. And if you look at the triangular section, guys, I'm sorry, okay? I have internet connection problem earlier.
Okay, doctor.
All right, thank you for understanding. Okay, now for this case, right, this is a compound section, right? So if it's this, if for example, the triangular section at the bottom right, the angle is given instead of one, the horizontal and vertical scale. So the side slope, if you look at the angle, right, the side slope is 1 to 1 lah, basically because it's exactly 45 degree. You know that when it's 90 degree, of course, it's just vertical line, right? There's no z at all. Okay. So now in this case, right, you need to find depth of flow. Okay. Here's the thing. The way I do it, right? Okay. Let's say let's look at this, right? The first thing that you have to evaluate, all right? You don't know whether why not is actually be within the triangular section or it exceed the triangular section. If it's just at the triangular section, right, that means you don't even have to consider for the rectangular section. So you know that as the depth increases, of course, the discharge of flow increases as well. All right, your Q is going to increase. Now let's check what is the Q for your triangular section. So what I did here, you know, Q1, I checked for my triangular section first. The formula is actually for triangular section. I found that my Q for triangular section is 0.4346 meter cube per second. Therefore, all right, I know that my Y naught is actually more than 2.25 meter. All right, so it's actually the flow, the depth of flow actually goes beyond my triangular section. So therefore, I have to account for both sections. If you look at it here, A is the total flow area, P is the total weighted parameter. I have to consider for this weighted parameter here. So I combine both sections, all right? The Q in question would be 23 meter cube over second. I substitute, therefore I get Y2 equals 0.762, all right? Now, of course, my Y1, I know already. I already substitute my Y1 equals to 2.25. The only unknown is Y2. Don't forget, Y0 is actually Y1 plus Y2. Therefore, if you look at here, my Y0 is Y1 plus Y2. Therefore, my Y0 is 3.01 lah. All right, meter. Now, can we continue next Thursday? Is it okay? Our class. However, all right, before that, I'm going to let you, I'm going to explain something about your project. Actually, could you, because you have already have your own group for your project, except for, I think, group 11, for group 11, you probably are going to have 2 members only for group 11, because I think Shuhada has already opted out from our section. Okay, so now I have already in author, I have already shared a link for a YouTube video where you can actually, this YouTube video I prepared for, the previous semester students to actually understand what the project is about. I could actually show, present now, the YouTube video. Okay. So this is the YouTube video, all right? It actually show how you are going to prepare for your, step by step, all right, group project lah, how you are going to do it lah. So I already shared the link, okay, in your author, all right? So I hope you could look at it lah. Now, do you have any questions so far? Guys, do you have any questions so far?
For me, I don't have any question,
All
doctor.
right.
If
I'm
I have
sorry.
a question, I will ask you at
Okay,
group
great,
or
great, great.
personally.
All right, great, thank you. Now, I'm really sorry because to this lesson there's a bit of hiccup, because due to loss of internet connection and things like that. I hope I could improve lah during the next class. I'm supposed to use 2 computers too lah, right? One is next time I'll just write down all the solution so I can guide you better, right, in solving it. I'll improve on my teaching, all right? I'll see you next Thursday. Is it okay?
It's okay.
Okay, doctor.
Thank you. Try out all the activities so far. I'm going to upload assignment 2 question and I have already uploaded the project. Start doing your project as early as possible because even though I give you the deadline, I think at middle of the June, right, or 12th June, you may submit earlier, all right, just to get rid of your, whatever assignment you have, all right. Yeah, ask me early. I don't want you to wait until the end, all right? Okay. I'll see you guys on Thursday.
Alright, doctor.
Okay, doctor.
All right, take care. Bye-bye.
Thank you, doctor.
Thank you,
Okay, thank you, doctor. Bye.
Thank you.
Thank you, doctor.
Thank you,
Bye.
doctor.
Bye.
Bye-bye.
Okay, bye.
Thank you, doctor.
Thank you.
doctor.
Thank you.
Thank you, doctor.
Thank you.
Thank you, doctor. Bye.
Thank you. Bye.
Doktor,
Ya saya.
yang memang kena guna try and error ke
Ya
untuk cari
betul.
why not tu?
Ya, lebih
Kalau
mudah. Lebih mudah.
kalau kita buat macam kita pindah-pindah je benda tu akan dapat jawapan sama tak?
Tak mungkin you boleh solve. You kena cuba jaya juga. You tak boleh directly solve. Cuba tengok. Sebab dia kuasa 2/3. Macam mana you nak buka? Kalau kita contohnya kita kuasa 2. Ingat tak? Start kuasa 2 sebabnya bila kuasa 2 term tu you darab sekali lagi kan? So kalau kuasa 2/3 macam mana you nak darab dia kuasa 2/3 tu? Betul tak? Alright,
doktor.
okay.
Terima kasih.
You're welcome.
Satu lagi
saya.
yang table soalan exercise yang sebelum ni, yang minggu lepas. Sekejapnya. Sekejap doktor. Exercise
4. Ni soal exercise 4 untuk
previous class yang minggu lepas.
Yang minggu lepas, okay.
Sebab saya sebab saya kan doktor ada buat table tapi saya kira saya tak dapat pun macam doktor punya table tu.
Exercise 4, okay saya faham. You tak dapat macam table tu. Okay, table tu mungkin ada kesilapan sikit sebab perasan tak saya buat kuasa 4/3 tau. Bukannya kuasa 5/3. Saya ada perubahan sikit.
Okay.
Alright.
Okay, doktor.
Okay. Saya jumpa you all hari Khamis Okay.
Okay, doktor.
Okay, bye.
Okay, doktor.
Jangan lupa hantar link video YouTube.
Okay, boleh. Okay.
Alright.
Bye.
Thank you, doktor.
Alright, thank you.
Bye.
Bye.